Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look at an example where we are finding the derivative f prime of a using the definition of a derivative for a function. Now, there is only one definition of a derivative, so if you see that, you are automatically using a limit, and I wanted to put the limit in there explicitly so that we see that that is going on. So we are going to be using a limit. We are also, notice we're looking to find f prime of a. We don't see an a there, we just see an x. So we are actually going to use that to tell us a little bit about what derivative we should be looking for. There are two different ones that we can use for the definition of a derivative. One is the limit where we have an h involved, and the other one is where we have an a involved. And so because we are looking at f prime of a, that kind of gives us the clue. This is the definition that we want to look for. So that is the limit as x goes to a of f of x minus f of a over x minus a. So that's what we're going to do. Now, first thing we're going to do is we are going to punch in our equations here. So we see our f of x here, right? F of x. So we're going to put that whole thing exactly where we see that. So we're going to just substitute the whole thing. So this thing is going to look a little bit ugly because it's going to have a lot of stuff in it. Our x minus a stays the same on our denominator. And instead of f of a, we are going to put in 2a plus 1 over a plus 3. So you'll notice what we do is everywhere we saw an x here, we're going to replace it with an a value. Same exact everything else, just replace your x with an a. All right, we've got our setup, and now we just have to do the algebra, which is actually the most difficult part for this. We have three fractions going around here. We've got our first fraction here, our second one here, and our third one, we see the denominator x minus a. So the first thing we're going to do is we're going to push these two together. We need a common denominator. We have an x plus 3 and an a plus 3. So let's multiply both of our terms to get a common denominator. So we have our first fraction, we are going to multiply by a plus 3. And if we do it to the bottom, we have to do it to the top. So it's basically multiplying by a fancy 1. For our second fraction up here, we already have the a plus 3, so we are going to multiply on top and bottom by x plus 3. And this whole thing still lives over x minus a. So there's a lot of writing and rewriting, but it's important that we don't lose anything when we're working through this. So we do have to rewrite everything. All right, now we can smush them together. A plus 3, x plus 3. I'm just going to leave it like that for now. And then on the top, we have a 2x plus 1, a plus 3, minus 2a plus 1, x plus 3, all over an x minus a. All right, so this still looks a little bit ugly, doesn't it? So let's actually start to reduce things. To do that, we're actually going to make this a little bit bigger first. We are going to distribute everything. So in our first bit, we get 2xa plus 6x. And then we distribute that 1 across, and we get plus a plus 3. I'm going to keep a parentheses around that. Don't forget, parentheses are our friends here, and the reason why I'm going to keep parentheses in a big square parentheses for a second one in particular is this negative sign here in the middle needs to actually distribute to everything that we see there. So we get 2ax plus 6a plus, and now we distribute that 1, and we get plus x plus 3. And again, our denominator is a plus 3 x plus 3, and that is all over again an x minus a. All right, now let's distribute our negative sign. So that is going to distribute to 4 different parts. You can do this all in one shot, but it is going to be a little bit of a mess if we do that. But it's easier to get things confusing if you try to do it all at once. You could lose terms, you could lose information, and you have to be careful because we don't want any algebra errors. And I've said this a lot, and I will say this again. The thing that stops most students from passing a calculus class is not the calculus, it's the algebra. So we want to be very careful with that. Now we see that some of our terms on top are going to cancel. The 2xa and the 2ax, those are the same thing. Plus and minus, plus 3 minus 3. And then we can scoot together our x's and our a's. So we have a 6x over here and a minus x. So we're going to get positive 5x. And then we have a minus a and or a plus a and a minus 6a. So it's minus 5a. Let's do this on the next page. So we get our limit as x goes to a. And once we cancel all that stuff out, we have 5x minus 5a all over x plus 3a plus 3 divided by x minus a. All right, here's where we're going to do a little bit of our algebra to make things a little bit easier. And I'm going to do this in 2 bits here. There are 2 different things we're going to do. Let's do a recall on the side. So here's our algebra tool of the day. When we have one fraction and we're dividing by another fraction, we can multiply, flip and multiply. And that is going to allow us to work with our fractions together. It's going to be so nice. And I know what you're thinking. We only have one fraction divided by, well, it's just one thing on the denominator, right? Not true. That x minus a is actually divided by the number 1. So we can always take whatever we have in the denominator and turn it into a fraction, which will allow us to write it as 5x minus 5a divided by x plus 3, a plus 3 times, and we're going to flip that, x minus a, and we're going to multiply. Okay. One thing here that we're going to do next so that we can get rid of this x minus a, and I didn't say this up front, we're going to pull out that 5. What I didn't say up front, of course, is that usually we try and plug in where x is going right away. You'll notice if we plugged in a, we'd be dividing by 0, and that's a no-go. So we had to do all this work. A plus 3 times 1 over x minus a. And now we see that because we're multiplying, those 2 terms are going to cancel each other out. Isn't that lovely? And we end up with the limit as x goes to a of 5 over x plus 3 times a plus 3. And now we can actually plug in a where we see the value x, right? So we're just going to plug our a value in right there. And we end up with, and I'm going to make this a little bit slicker, 5 divided a plus 3 quantity squared. So there's our solution. And isn't it lovely? Don't forget your nice algebra trick here. Whenever you have 2 fractions that you're dividing one by the other, take your one in the bottom, the fraction in the bottom, and just flip it and multiply. Thank you so much for listening.